The last thing we're going to look at here is kind of a funky geometric pattern called tessellations, where tessellations are kind of the idea that tangrams and jigsaw puzzles are built off of. So hopefully some of you guys are excited to hear that, but I imagine a few of you are more like me and kind of nervous about that thought because I'm not a big fan of jigsaw puzzles. But anyway, the idea with a tessellation is that we're generating geometric patterns like what should be popping up on the screen here, where everything consists of repeated use of the same figures that completely cover a plane with no gaps and no overlaps. Now, the big thing, the big property for our tessellations is really a basic property that the sum of angles around a vertex, that is, the sum of angles around a point where these geometric shapes meet, is 360 degrees. Again, should make sense because you go all the way around a full rotation is 360, and this should capture a full rotation. Now, the trick for doing this, or what makes these types of things difficult, is trying to figure out how you can do them with just one shape. For example, if we want to do this with regular pentagons and nothing else, we could see that if we tried doing that, because pentagons will have 5 angles, and as we saw in our previous example, the sum of angles in the interior of a pentagon is 540. That means each of those interior angles for the regular one has measure 108. The problem there is you can only meet up to 3 of them around one vertex, which would get you to a value of 324. That means you got 36 left over. You can't get that 36 from 108 without there being something stuck on top of something else, without there being improper overlap, and you can't fill that space with another pentagon, with a pentagon that has an angle on the interior of only 36, while maintaining regularity. So in a lot of cases, like this one here, it's actually impossible to be able to properly form a tessellation. The sort of problem we usually look at with these things, the sort of thing you're going to be doing in the homework, and probably that'll pull up in one of the worksheet problems, is figuring out how you can identify some of those interior angles using information about the shapes that form around vertices, and maybe a bit of those special patterns in terms of general sums, whether things are regular, and if they're special shapes, like, say, rectangles or right triangles.